In this video, we will be looking at general hints on physics practical questions on WAEC, May-June examination, and November-December examination. The content we will be considering in this lesson are: one, we'll be looking at instructions on receiving your question or papers for your physics practicals. Observations, we'll look at the graphs, determining of axis and scale, plotting, forming your table of value, scale, slope, your x and your y axis intercepts, and precautions. To proceed with the observations, the students are expected that once they receive their examination question, the first thing they should do is to read the question carefully, go through it, and know the things they are supposed to do. For the first 15 minutes, students are expected to read their questions. Once they have done reading their questions, students are also expected to choose from the 3 questions before them any 2 that they will be able to do conveniently. Apart from that, students are also to check the apparatus that are set before them to ensure that these apparatus are working effectively. For those of them that have to do with ammeter, voltmeter, galvanometer, they must ensure that those apparatus are at 0 error. Also, students are also to enter their readings directly and avoid the uses of sheets of paper, so that they will not be wasting time in trying to transcopy back into their main answer sheet. So students are expected to do all their work on their answer booklet to avoid time wastage. Students are also to work economically and steadily to complete both practicals. The Part B questions, they should also to keep their eyes on time while they are working. Students must ensure to form their table of value for each experiment as they work. Students are always encouraged to tabulate their readings. While going through the instructions, they will come across some phrases that has to do with measure and record, read and record, evaluate, calculate, and tabulate, and sometimes tabulate your readings. Students must take notes of these questions and ensure that the quantities that are stated on the table, they have their unit well stated also for each quantity at the top of each column. For example, looking at what we have on the screen, you see a question: read and record the values of R, I1, I2. Calculate Z equal to I1 all over I1 minus I2 and inverse R in each case. Tabulate your readings. The above statement is a statement that is indicating how your table will look like. Now, which means that in your table, the students are expected to have a column for arrow. And from the experiment, we know that arrow stands for the resistance and it's measured in ohms. I has to do with the current. So we are going to have another quantity on our table, current, and current are always measured in amps. So the unit of current must also be indicated. Z is another that the students are to determine. Also, inverse arrow. Inverse arrow is the resistance, inverse resistance, and so the unit will also be in inverse ohm. So students are to take note of this. In each instructions that are given them, they will be able to form their table from it. Just like I said earlier, that all values should be transferred into your workbook directly. Avoid the use of sheet of papers. Now, when students are taking their readings, you notice some raw values will be determined. For example, you are given resistances. You are also given the current and the voltmeter readings for your voltmeter and your ammeter. Whatever reading you read from these devices are known as your raw values. And these raw values should be presented in at least 2 decimal places. But in calculated values, students are encouraged to leave their calculated values in at least 3 decimal places. And also note that across a column, same decimal places must be used for all data. Example, if you look at what we have, the table before us, in the column of I1, you notice that for resistance 10, we have that the ammeter reading is 1.25, and that decimal places is maintained, 2 decimal places is maintained across the column. In our calculated values, where we have 3 decimal places, we can also see that across that column, 3 decimal places are maintained for each data in the column. So students should take note of this and avoid the use of different decimal places in a particular column of their table. The next thing we are going to be looking at is graphs. Most practical questions will require students to plot graphs. And graphs have some advantages which are shown before us. Example, if P is plotted against R, the relationship between them is shown pictorially. Corresponding values of P and R other than those actually observed and recorded can be read from the graph. This will be discussed in as we move further in this lesson. A known or expected relationship between P and R could be verified, and numerical values of constant occurring on the relationship would also be determined. If the relationship between P and R is simple but not known or expected or suspected before the experiment, a graph enables one to discover the form of this relationship. So the place of graph in our practical examinations cannot be overemphasized, because some hidden values which are not necessarily stated can be determined from the graph plotted. The next thing we are going to be looking at is axis. The axis of each graph should be correctly labeled. Avoid the use of y minus and x axis if you are not asked. So if one is asked to plot the graph of T, which is temperature, against P, which is length, it means that T should be the label for your graph. We know that your vertical axis is always your y-axis. Your horizontal axis is always your x-axis. What we are saying here is that students should not label their graphs to be y and x axis, since what they were asked to plot is not y and x axis. If you are asked to plot a graph of t against p, it means the label on your graph will be t against p instead of y against x. This should be noted, and the unit of the quantities that are required or to be plotted must be clearly stated. One should use sharp pencil to mark the points plotted across with a cross or dot or circles. The most complicated state in graph plotting is in choosing the right scale to use. Here are some suitable steps that one should ensure to take for a suitable state for their graph. A. Choose a suitable scale which covers at least 1/3 of the graph. Once you have your tables of values completed, the next thing is to choose a scale. Students are expected, first of all, to cover over 1/3 of their graph books to get suitable readings. So in order to do this, students must ensure to choose scale that the highest value on their graph must be at 1/3 of the graph or above 1/3 of their graph. Students should also avoid the use of prime numbers in choosing their scale, and also avoid the factors of these prime numbers. Example: 3, 5, 7, 11, 3, 13, 15, 17. These numbers are numbers that can only be divided by itself and 1. Students should avoid using this set of numbers in their scales. Also, the cm that will be used, this should be avoided. When one is required to start a graph from 0, it means that the scaling should start from 0 and not that the graph should pass through the 0 origin. Students make this mistake oftentimes. When they say that you should start your graph from 0, most students think that the graph must start from origin. No. What we are saying is the first point on your graph should be 0. That will be displayed in this work as we proceed. If you don't need the values that are needed, the graph should be plotted using zigzags. This will be explained in our graphs as we move on. At times, students are confronted with kind of data that the first data they have is far from what should be. For example, the table we just presented earlier shows that from 1 to 40, what we have in our plottings does not fall within those numbers. Our first number could be from 40. So when we are confronted in such situations, what do? Students are expected to use zigzags to indicate, whereby the zigzag indicates that the values between 0 to the time to the point 40 are not required, so that the highest value can be plotted on the graph. That is the essence for this, and this can be done in both axes of the graph or in one axis, as the case may be, depending on the axis that has such values. So when students are confronted with the kind of tables that their first value is far away from initials, they are expected to use zigzag line, which will draw them closer to the required values. But if you are required to start the origin from 0 and you need the values between the origin and the first data, then these above methods are not necessary. If you are expected to start your graph from 0 and say from 0 to your first value, you need them. It means this step above are not necessary. But when the numbers between 0 and your first data are distant away, you can make use of this method stated. Plottings. Students often find issues with approximation in their graph work. But the truth of the matter is this: the exact values obtained on your table should be plotted, and students should avoid approximation of their readings. Students should also avoid matching of values, like you can see in this table presented before us. Approximation, most students tend to plot their graph with just say on the vertical axis where we have I plotted 0.92. You see students plotting 0.9, forgoing the 2, or approximating Y plotting, which is different from what they have on their table. Students should avoid this, and it is not a good practice in graph plotting. You can see from the graph plotted here that the points are just indicated with dots instead of plottings. Also, I want to bring to the notice of the students here that in drawing their lines, at least 2 or 3 points should be connected. We are familiar with the basic knowledge that for a straight line to be drawn, we need a minimum of 2 points to connect these lines together. That can be applicable here in your graph. So when you have finished plotting the point or indicating the coordinate of the point in your graph book, one is expected to connect these points together. Now, and in doing that, 2 points that are straight together can be aligned. Also, when choosing the point to connect on a line, one should also ensure that if we have more than 1 point that does not fall on the line, the 2 points should be scattered on both sides of the line. You can see from the graph here plotted that 1 point that is not falling on the line is above the line. The 1 point that does not fall on the line also is also found below the line. Students are at least encouraged to draw 2 or 3 points together to ensure a straight line is gotten. Now, let us take for example, we have a question here before us. You see the diagram is also there to show us how the apparatus are being connected to each other. Once students are confronted with cases like this, they are to follow the guide on the diagram to connect their circuits. And from the instructions that is given, students will be able to form their table of values. Now, from the diagram we have above, we notice 2 points P and J, and between them we have L. We notice the resistor arrow. We notice the cell, batteries, and a switch, ammeter. The point PQ is the potential meter. So students is expected to be able to connect this circuit using the instrument provided. So when you are confronted with materials like this, you have to check your ammeter which is provided. Is it working? And if it is not working, students are expected to call the attention of the lab attendant to react to this and make changes where necessary. So from this instruction given, we can be able to determine the table. You will see from point I. It says use the jockey to make a point with PQ at 20 cm. Mark such point PQ to be I, which means in our table we are going to have the quantity I, which indicates current. You also have where it is given, read and record the values of I of the ammeter. Evaluate I inverse. So with this, we have seen what will be on our table. In IV, we have repeat the procedure for other values of I, 35, 50, 60, and 80. So we already have the values of I. Initially, we were to do 20, and we are also given others in 35, 50, 65, and 20 cm. We've already gotten our table. The next instruction says, tabulate your reading. So this is what we have discussed earlier, that from the instruction given to you, you can be able to form your table of value and do the needful. Here you can see the table of value obtained from the instructions we have just considered. Students at all times should feel free to pause this video and go through the instructions themselves and try to see if they can get the same table. You can see L is giving us, I1 is giving us, L inverse is also giving us as the instruction is. So this is a table we could get from that instruction. We are going to be plotting a graph which will determine the slope as it is shown here. The graph plotted to determine the slope or to arrive at the slope will be displayed as we move. Here you can see the graph that is before us. From the table of value we have, we notice that the values that should be plotted on the horizontal axis from the first point to point 0, we notice that those values are not necessary, are not needed. That is why we use zigzag lines in this point to draw closer to us the values that are needed on the table. Students following up this video are expected to pause, go back and see the nature of table we have that has warranted us to do this. Also, from the graph plotted, students will know that plotting lines were not indicated apart from the slope lines and the places that were taken to determine our x1 and our y1 as the cases may be. The slope taken for this graph is clearly stated on the table above. Students are expected to pause this video and go and observe this for themselves. Try it and see what you got. So from the slope we have that our y1 is equal to 0.029 minus y1 equal to 0.015, and our x2 is equal to 0.1 minus the x1, which is equal to 0.8. When we do this simple mathematics, we observe that our slope is equal to 0.014 all over 0.1. And when we do this division, we have that our slope is equal to 0.14. Our expectation here is to form the table from the list of instructions given to us. First of all, students are provided with a knife edge, a meter rule, set of masses, and a string. which could be a thread. If you go through the instructions given us, you will see that we are to determine and record the values of x. X can be seen on the diagram. So students are guided on what x is. Also, we are to evaluate the inverse of x, which means I will have x on my table. I'm also going to have inverse x on my table. Also, students are also to find the values of m, which are 70, 90, 110, 130, and 150, which means I will also have m on my table. So you can see from here that we've already gotten our table. Other things one should do is to tabulate your reading, having x, inverse x, m as the columns of that will form our table. Slope is to be determined at the end of the plottings. So with this, students can be able to form their table. So you can feel free to pause this video and try to follow the instructions and see if you can form the table on your own. Here you can see the nature of the table that has been formed from the set of informations or instructions that was given us earlier. We have m, x, and inverse x. Also, I add a serial number to indicate the number of times that this will be done. The slope you see plotted here will be displayed and explained by the time we must have finished plotting the graph. Here is the graph that is plotted from the list of table of value that we derived or formed from that experiment. You can see that in this case, the coordinates are plotted using what? Plus signs. And you can also see that we have in the line 3 points falls on the line, and the point that does not fall on the line are scattered abroad on both sides of the line drawn. The slope is determined. You can see the values of m2, m1, and the other inverse x that is plotted. You can see that on the graph, and the slope determined is also indicated. You can do this on your own using the formula of determining the gradient of the straight line. You can get the slope of the graph. Students are expected to feel free, use the table of values given in this video to plot graph on by themselves as they determine the scale and axis that will be suitable to obtain good plottings. The slope that was applied in the two examples we have done so far is here now giving us. A large slope is obtained by considering any 2 points which are well placed on the line. The 2 points that will be considered should be placed on the line. And when we do this, we are going to see that a right angled triangle will be obtained, from which the formula of the gradient of a line can be used to form the slope of a given graph. Now we have a case where the line will be curved. So in such cases, what do? We take the tangent of such points, just as it is indicated in this video. The slope at the point P is the slope of the tangent to the point. Slope of the line can be positive, negative, or zero. It is positive if the line makes an acute angle with the axis directly or when it produces it in a negative. It is negative if such angles are obtuse angles. You can see that. Feel free to pause the video and observe this for yourself. So students are expected to note this as they approach writing their practical examinations. There are cases when students are expected to determine the intercept of on their graphs. And what do we mean by that? We notice that in drawing a straight line most at times, instead of the straight line passing through the origin, it cuts on either axis of the graph, the y-axis and the x-axis. So, it will always be specified when needed that students should determine the intercept of the graph on the y-axis or the x-axis. When this is stated, it will also give students a guide that the graph, the line will cut on the specified axis. So students must be careful at this point. And for students to know the exact point where the line intersects on either of the axes, this is where the scale they choose it comes to play. From the scale, students can be able to determine that. Now, most at times, these lines will not cut at the measure point where you calibrated. It may cut in between the two small boxes on your graph or even on a box in the graph. And if you don't know what your box is, it means you're going to be finding it difficult in doing that. As we move on, I'm going to explain this to us. But let us note that when your straight line cuts either the vertical or the horizontal axis of your graph work, you may be asked to determine the intercept. And when that is done, it is not a big deal. All you are required to do is to look for that point when the line intersects and read it out. The next thing I'm going to be talking about on this video is precautions. Students will be asked to give precautions, at least 2 precautions that they followed to ensure that the experiment was carried out successfully. And this is anything you have done during the performance of the experiment or would have done in the case of an alternative practicals. Students should not make mistake. In your May June examination, it is expected that you did the practicals yourself. So the terms used, students must be cautious. When you use I would have ensured, when you are writing a May June exam, it means that you are not the one that did that experiment and you have only succeeded reporting yourself. So in your May June exam, the statement is I ensured, which means that you did the work. For those of them that will be writing GCE and will be required to plot graph doing alternative practicals, the statement that will be used is I would have ensured. Reason being that you are not given the materials to do this, carry out these practicals. You're only given pictures to read the values that are necessary where these things have been done already. So you are telling us that if you were the one that has carried out these practicals to obtain these values, that you would have followed these precautions or preventive measures to ensure good result. So that is what your precaution is all about. Now, students should avoid to use command language such as you must. You are expected to use I did. When you say you must, it's a command language, and that is not what is expected. We want to know what you did, and you personalize all your statement. Example, I ensured that. In this case, in the case of alternative to practical, you are expected to use I will do or I will ensure that. So these are the common precautions we will encounter in different stages. When you are confronted with experiment that has to do with mechanics, say simple pendulum experiment, you can see the precautions that is attached to that here. Where you'll be given a pendulum bulb, you will also be given strings. So in such cases, you'll be given rector stand. In most cases, you know that this experiment is to be done in an airtight corner. So precautions can be derived from that. I advise that you go through these precautions to see the precautions that is suitable in each cases. You can see that when you're doing principles of moment experiments, you can see that when it has to do with Hooke's law, as we move on, you're going to be seeing other experiments. In the case of experiment that has to do with light, when students will be provided with mirrors, most times triangular or rectangular glass prism, you can see lenses, the experiment, you can see the precautions needed. When students are doing optics lenses, you can see when experiment that has to do with heat, you can also see the precautions that will be suitable are provided here. So students are expected to pause this video, study this experiment, so that once you are confronted with a practical, you know the kind of practical you're doing. It will guide you in the precautions that will be needful in such practical. You can't be doing experiment on light. You are given optical pins, you are given triangular glass prism, and you are given precautions that have to do with heat. It does not correlate. So students should take note of this. Here you can also see an experiment that has to do with electricity. From the apparatus that are provided, you can see the list of precautions that can be taken to ensure accurate reading and a successful running of the experiment. Please do well to subscribe to this channel so you can be receiving notifications once we drop new videos. Also, for consultancy and sponsorship, you can call this number. Do well to drop your comments on using this email address posted here. Thank you very much. God bless you. See you.